Hi, everybody. All right, so let's get started. First of all, I'd like to say thanks to all the conference organizers for inviting me to be here. This is actually really special. Falcor is a project that I slaved a good almost 2 years on, so it's really cool to come and get to show it off to everybody. Before I get started, my t-shirt right here, I have a bunch of these, and hoodies too. So if anybody wants a really cool Falcor t-shirt or hoodie, let me know, because I'm not taking them back to the US. My name is Paul Taylor. On Twitter, you can find me at TREXcellent with no vowels. People think it's related to Trick cereal, and it's not. I was a founding member of the UI platform team at Netflix, and my first project was Falcor. So I guess let's get started. So we started with the idea of Falcor with the observation that every user wants to believe that the entire cloud, like all the data out in the cloud, is on their device. Users behave that way. They constantly scratch at the screen until the data loads. Like, we're really just impatient. And that's fine. So then we let ourselves know, well, that's obviously not true. You know, we know that's not true, but what if we could code as if it was true? And that's where we started with Falcor. But before, actually, I don't know why my notes aren't showing up. This is, nope. So, all right, cool. Okay, so going back in time a little bit, even before I was at Netflix, we had the concept of REST. And we asked ourselves, like, what's the most successful distributed system ever designed for browsing information? And obviously, it's the World Wide Web. And now this isn't going forward, so I'll just do it on my computer. There we go. And that's great, because Netflix ultimately really is a browsing problem. Users just scroll through an endless library of movies for hours at a time, trying to figure out what they want to watch. And for a long time, Netflix had a RESTful API. Pretty standard. You request movies or lists by IDs, and then the server returns you the data. But the services weren't granular. So as Netflix expanded and built more complex user interfaces, we found we couldn't, this wasn't flexible enough to build user interfaces efficiently. Because we had sort of monolithic services that would return you lots of JSON. Well, what happens tomorrow if we introduce a new A/B test and half the users don't need that data? Well, they're downloading it anyway. So we started building, that's House of Cards. So we started breaking up our services into more granular services. But then we got slammed with the idea that, especially on mobile devices, there's a lot of latency, especially on cellular connections. Just every single network request you make has just some latency in the network. And that's really an artifact of how HTTP was designed. When it was designed, the web was a place to get things like documents and text files, maybe small little executables. But nowadays, the web is a place to do things. We have web applications that will tend towards more granular services. So web pages serve small amounts of large resources, but web applications serve large amounts of small resources. So in 2010, as we transitioned into being a service that was on more devices and everywhere, much more dynamic, Netflix's RESTful API became a restless API. So we took all of our URLs that we had that used to be unique, that the browser could just cache, and we started adding dynamic properties to them. This is the other great design pattern for distributed systems is RPC, remote procedure calls. Each different platform could say, all right, this is my state, this is the stuff that I care about. But then we don't end up with our unique URLs anymore. then all of a sudden our resources aren't cached. Because with RPC, you might be requesting for the same piece of information via a different URL. So yeah, same info, two different URLs. So what we wondered was what sort of programming model could give us the caching benefits of REST with the loose coupling that we get through HTTP redirects, but then the small message sizes and the low latencies of RPC. And that is where we got to Falcor. Get some water real quick. Really should have done this before the talk. So Falcor, what is it, beyond a really cool name for a project? Well, I'll tell you what it's not. It's not a replacement for your database, your MVC framework, or your web server. Falcor just fits into your existing stack without messing things up, but it allows all the layers to communicate more efficiently. So what we do with Falcor is it's a combination of a local client library that creates an in-memory cache and the idea of a big JSON object in the sky. And effectively, that JSON object bridges the gap between your client and your distributed systems everywhere. If you know anything about Netflix, it's a massively distributed architecture on the back end. But we don't want to burden the client with that information. Let's see. So on the client side, it gives you an async model, an instance which you can new up and you can request data for, just like you would if it was if you were using REST, but so with the same paradigms, but you don't know that it's doing the caching for you. The async model also allows you to execute remote function calls, but in a way, like function calls have side effects. Like if you add something to a list or remove something from a list, you need to be able to communicate those side effects back to the cache, through either invalidations or value updates. So how does this work in practice? So ideally, the server implements, at least at Netflix, the server implements what we call the Falcor router. And the Falcor router is that big virtual JSON object in the sky. It doesn't exist. It would be too big to hold in memory on any one machine because it's just tons and tons of information. But we're going to pretend like it exists. So the client, when it's going to load up and it needs to render the view, the client locally will ask its async model for some small part of that cache. The async model knows that it doesn't have it because its cache is totally empty, and it goes to the server and tries to get it back. The server says, oh, cool, yeah, here's this little piece of data. Here, sends it down, and the client can store it in the cache and fulfill the request and render the screen. So then the user starts interacting with the application, and they do something else that we need data for. So we just do the same thing. The cache goes and says, all right, cool, give me that little piece of the cache, and then we can render the next screen. And lastly, get this next one, go into the movie details there. And now we've got like some small part of our large JSON graph in the sky locally. But what happens when we go back? So if we hit the back button and go to this screen again, we'd be making the request for the same piece of data we already got. But the async model is smart enough to know that it doesn't have to go to the server to get it. So it can fulfill the, on the client side, it can render the view synchronously without the view you having to change any code that you wrote. So what does Netflix look like on Falcor? It doesn't look like an omelet, I'll tell you that. The Netflix domain model is ultimately a list of lists. It's just a list of lists. They call it a LOLIMO. Each list contains titles, and each title has little bits of information about the movie that you're looking at. But as you notice right here, we see House of Cards, and it's actually in two different lists. We've got House of Cards in recently watched, but also House of Cards in new releases. So we've got some amount of duplication there. But what really that means is Netflix's domain model isn't a tree, it's a graph. So here you see the same title friends in 2 different lists. And on the server side, really, it's a graph. But when we send it down to the client, how do we, like it's just JSON. JSON is a tree. How do we communicate that to the client that it's actually the same resource? Traditionally, if you have a graph on the server, which lots of people have graphs on the server, and you need to communicate the graph down to the client, you kind of have to serialize it into a tree and create duplicates, give it IDs of some sort, send it down through the big cloud, and then your UI has to somehow reconstruct the graph. There's like 2 really big problems with this. The first is that you incur the network cost of duplicating data. So for someone like Netflix who has a large server bill, that's obviously problematic. But also you incur the cost on the client side of all this complexity. That why should you care? It's not your problem. Or shouldn't be. Oh, wait. There we go. So JSON graph. JSON graph is this just idea that really is the secret sauce that powers Falcor. It allows Falcor to do the intelligent caching, batching, and deduplicating of requests. So on the server side, if we had our entire JSON model in memory, then we wouldn't have anything to worry about. But since we can't have that, we create the idea of a JSON model in the server and hide it behind our Falcor router. So having Falcor on the server gives you the caching benefits of REST so that the client doesn't have to make duplicate requests. The client can make small requests as it needs and have those requests batched up. So it's actually using kind of one of the features of HTTP is that you get lots of data all in one, like Falcor would batch that up and make multiple requests in the same go. And then it also supports function calls. So in this sort of straw man user interface model right here, if we have some sort of controller that's going to broker communication for the view doesn't know or care like where its data lives. It just knows it's going to get some and then render its pixels. The Falcor model sits on the client, and the controller just asks it for some data. Whenever the Falcor model eventually resolves, gives the data back to the controller, and the view is just saying, all right, if you're using observables, it's really easy. This is an example using Angular 2. You can just drop them straight into your template. Let's see. So the paths that we create conceptually are RESTful. They're based on unique IDs. There are references along the way that allow us to do path optimization. But we use RPC to send over because we use an existing network transfer protocol. So the browser actually can't cache our requests. We have to do all the caching, which is fine. It's really not that bad. So the server sends us down this little piece of data. The controller sends it down into the view, and the view gives us some HTML. And that's the story of how Netflix is able to share the same data model across radically different user interfaces and platforms. Thanks. Now, I know I finished kind of early, but I'm happy to answer any questions. All right. I'm going to go with anonymous first, because I can see Andre's thoughts in the... how does Falcor compare to Relay and GraphQL? It's really interesting. When we were building Falcor, we had a few meetings with the GraphQL team just to present what we were doing, hear what they're doing. Falcor is really, the idea of Falcor is, what do we need, like, what are the minimum set of like operations and things we need to make working with a JSON object on another machine feel like we're working with a JSON object on our local machine. the data is the API. So Falcor isn't doing things that JavaScript wouldn't normally do. So if in JavaScript you don't have comprehensions or predicates, you have to drop down and actually do programming stuff with that. You can't just create queries. So we didn't try to write a query language. We wrote kind of a DSL that allows you to describe how you might retrieve lots of data in a single array. For example, if we wanted to retrieve 50 movies, but we wanted to retrieve them by index, we didn't know their ID yet, and we needed to render a list that was 50 long, rather than send an array of integers from 0 to 50 to the server, we just said, all right, well, we'll standardize a little object that has a from and a to, so we can say from 0 to 50, and that kind of just does compression right there. That's about the extent of the sort of DSL or query language that we implemented for paths. I have no idea how GraphQL expects to be able to predict that they can retrieve data from cache whenever they've got dynamic predicates, but they're also a lot smarter than me, so they probably know the answer. Is that sufficient for everybody? Andre. So Netflix is mostly a read-only or browsing experience. How does it perform in cases where reads are as often as writes? So I think it's a common misconception that Netflix is a browsing experience. You might be surprised to learn there's a lot of writing happening too. Maybe it's just not users causing the actions to occur. So in Falcor, when you set something, you set a value through the cache. First, we set it locally. Then we bundle up that set and we communicate it back to the server. But there's a special protocol. The server can say, no, you're wrong, because we might have concurrent writes, or we might have some information might have changed in the server, and now that user, their credit card's declined, or they're not authorized anymore. So the server can always send us back it's the source of truth, in a sense. So it performs pretty well, actually, in cases where I'd say reading and writing are about equal. And you can use it as sort of an immutable store. There's some new UI work being done in Netflix to use Falcor as an immutable store for, well, it's not technically immutable, but it reports to you the results as if it was immutable, as a store for your React application state. Cache invalidation, cool. These questions are more in line with what I did, because I wrote the internals, so cache invalidation is really near and dear to my heart. So with Falcor values, values can have metadata. We respect just a few little pieces of metadata that we built in features for, but you can add your own metadata and do special stuff with it if you want. But specifically, we have what's known as timestamps. So you can say, all right, the value on the server is newer than the value on the client, or vice versa, the value on the server is older than the client. We actually have that problem on TVs when you're like watching a movie and you've like fast forwarded. Your bookmark on the TV is about 8 minutes ahead of the bookmark on the server. So if you were to watch a movie, store your place, leave the movie, come back within 8 minutes and watch it, the server would tell us that you're where you were when it last knew the value 8 minutes ago, and not where you actually were when you stopped playing the movie. So what we do in cases like that is we tell the server, no, we've got a newer timestamp than you. But conversely, we also have value expiry. So you can set an expiry metadata, say expires at an absolute time. It expires, let's say, 5 p.m. today. So when the cache is going through and reading things, if something is expired, it's older, then it treats it as if it wasn't there and tries to go and get it again. You can also say expires with a relative time. So you can say this thing expires 30 seconds from now, no matter what time of day it is. And then lastly, there's a manual cache invalidation way. So you can take your model and you can say just blow these things away, get rid of them, and it'll just completely clean them up. And also because Falcor works under memory-constrained devices, whenever the model keeps track somewhat of its size, and if you give it a max size, it'll start kicking things out as best it can if it starts going over that size. Which should be all right, because if something goes out of the cache, next time you request it, we can just go back and get it again from the server. So, pagination, lazy loading. So we don't have sort of a native implementation of lists or pagination. We have kind of a standard or a convention that we use for lists. Essentially, in JSON, you could treat an object that has keys 0, 1, 2, 3, 4, and a length of 5 as if that map were a list. So typically when we have a list of things like one of our lists of lists, we can say, first, all right, cool, give me the length of that thing, and so I know the total length, and then make a follow-up request and say, well, I don't need all of those things, I just need the first 15. And as you're scrolling, you can just keep making more requests to the server. That might change sometime in the future, but for now, that's the convention. Optimistic updates. Does whoever asked this question, do you mean push data, like push notifications and value streamed to you, or what's the context for that? Yes. Yeah, so optimistic updates, we called that optimistic concurrency. So if you do a set, like on you set some data in the cache, until we hear back otherwise, we'll pretend like it succeeded. You also run into some interesting problems where, let's say I do a get for a large list of paths. I'm going to get the movies for the first 10 lists and the 75 movies in there. But let's say I'm on a memory-constrained device. I might get some of that data, merge it into the cache, kick some of it out, and then not have it by the time, like I might be waiting on multiple requests. I might have had to split that request across, or split the request for paths across different network requests. So we have this problem where we have to figure out constantly, all right, did we kick some data out of the cache that we really need now, and so now we have to go back and get it again. But eventually it all kind of settles, and we have all the data we need. Developer preview. We use the word developer preview because really it was me, Jaffer, and Michael. And Jaffer was architecting it and didn't really code it. So it was kind of just two of us. And we didn't really want to take the heat if anybody got into trouble. But now I'm not at Netflix anymore, and Michael's on paternity leave, so we've got some other really good people working on it, but they're ramping up. Developer preview will eventually go away, but I can't say when because I don't work there anymore. But I can say absolutely it's in a production-ready state. We've been using it. The new Netflix UI that launched last Christmas, the new TV app that's launching, the new phone and tablet. There's a version of Falcor working in Objective-C that we expect to open source, last I knew. There's a Java client that I think just got open sourced. So as far as like production-ready, Netflix is using it, and that's why we didn't even want to release it before you were running in all of our UIs. So that's kind of how we did things. Some kind of support for managing. Yes, managing permissions. Yes. On the Falcor router, there's an authorization. You can only be authorized for certain paths. There's a way that you can configure that, and if you're not authorized, then it'll send back errors to the cache on the client, and you can handle those errors if you need to. Will we get live updates? Maybe. I can tell you that there's some amount of it that we'll have to rip out to do that. but I thought about doing it last weekend, so maybe. It's open source. we can all work on it. How's Falcor different? I have no idea how Falcor is different from Meteor's DDP. I have no idea about that. I do see advantages using service workers in a networking caching layer. We actually experimented with that on iOS, and it worked really well. I think it only worked if we were able to get our data as binary data and pass it back, because it's always doing copies across threads, but it was very, very fast. Oh, so why does Falcor weigh that much? Because it currently has RX in it, and it's not going to have RX in it in a little while. And I think we brought the size down to something like 68K, and maybe less. I mean, honestly, it was 2 years of like going really, really hard, and also everything changing all the time. So there's a lot of legacy, at least that I know about, and some of that is that we just used RX internally. So no, it does not mean you have to model your data as a graph on the server. There's actually, I guess I should, if you go to netflix.github.io/Falcor, you can see all of the demos and examples. There's one called the Falcor Express demo that specifically uses PouchDB because it doesn't really need to be deployed, but you can just run it locally and see how you could implement a router, and calling into your databases. That's exactly the idea, is that you transform it on the fly before sending it. It's like your server doesn't have to know or care. You just put it in a format that the client can efficiently cache it. Yes, it is ready to work over HTTP2. So Falcor models have a data source. It's just an interface with a get, set, and a call method. Right now, there's an HTTP data source. The Falcor router actually implements the data source, so you can actually run the router and the client, both on the client. And so all you really need to do is write a data source that uses HTTP2 instead. Client-only data. Falcor. Yes. Well, so Falcor is not a replacement for Flux by any means. Falcor is try to be as bare bones as possible. It's just a library for getting data.
So let's do one or two more questions.
Cool. Right. So.
Sorry. There's a lot of questions here. That's very good. There's going to be a discussion. What we can do is during the break, we have one room specifically prepared for this kind of situations. If there's more discussions that you want to have, and you can go to the room on the left at the very end. And Paul, you're going to be there. You can do one-on-one discussions and talks.
I'll be giving out T-shirts.
Giving out T-shirts, exactly. So let's do one last question from the Slido slide,
right.
And then we're going to move to a coffee break. So
yeah, somebody else. Who wants to vote? Does anybody want to vote on the question, or should I go by the thumbs, or just the top one?
The thumbs is the voting, actually.
All right,
yeah.
All right, JSON API. So JSON API is more complicated than us. We're not trying to define a schema. The cache has very few conventions. And the idea was that your data is the API. There's really only one or two like special types of objects inside the Falcor cache, and so just so that the cache searching algorithm can, delineate references and follow them and optimize the paths. But Falcor doesn't try to tell you that you need a schema and you have to follow some rules.
Great. Cool. Awesome. So Paul, thank you so much for your talk.